right, this is the last bit. It's working backwards to find the error bound or sample mean. And I left this all here so you could study it even when I'm not here to talk to you about it. Sometimes, if you only know the confidence interval, you can work backwards to find both of them, error bound and sample mean. Finding the error bound. From the upper value for the interval, subtract the sample mean. Or, from the upper value for the interval, subtract the lower value. Then divide the difference by 2 to get your error bound. To find the sample mean, subtract the error bound from the upper value of the confidence interval, or average the upper and lower endpoints of the confidence interval. There are 2 methods to perform each calculation. You can choose which is easier with what you know. So here you go. Suppose we know that a confidence interval is 67.18 to 68.82, and we want to find the error bound. We may know that the sample mean is 68, or perhaps our source only gave you the confidence interval and did not tell you the value of the sample mean. To calculate the error bound, these are the 2 ways that they told you. Okay, upper value for the interval, subtract the sample mean. Okay, if you know the sample mean is 68, then you can just subtract it and that'll give you your error bound of 0.82. If you don't know it's 68, then you subtract your you subtract your lower value from your upper value, 68.82 minus that, divide by 2, and that'll give you your error bound. Okay? Calculate the sample mean. If you know the error bound, you went ahead and figured that out. You just subtracted from that interval, and it'll tell you that is you're undoing what we did before on, and I'm pretty sure it's gone now. On the earlier slides where you added the error bound, you're just subtracting it back off to get to that 22. So that's what you're doing. You're undoing what was done. Okay? You know the error bound, subtract it off and get it, or take the average. Midway between these two is going to be your mean. Okay? So, here it is right here. Suppose we know the confidence interval is 42.12 to 47.88. Find the error bound and the sample mean. Okay, now remember, all we have is the confidence interval, so we do not know the sample mean. So you are going to subtract this one minus this and divide by 2. So that's exactly what we're doing here. 47.88 minus 42.12 divided by 2 is going to give us our error bound. Okay? So, let's see. 47.88 minus 42.12, 5.76 divided by 2 equals 2.88. All right, so now if you want to find the sample mean, you're going to say 47.88 minus 2.88. It's going to give me 45. Is my sample mean. Now they showed you the other way to do it as well, which was add the 2 together, but since we already had that, it's just a matter of subtracting it off to get back to the mean. But you could very well add these 2 together. 42, 12, 8, 9, 10, 7, 9, 10, 90. Divide by 2, which would also give you 45. It's just whether or not you had to find the error bound first. If you didn't, then there you go. Calculating the sample size. Okay, well, the only thing we've got on sample size, your error bound right here, is that multiplier. And remember, we did that before. Your multiplier, the 2.58 times what we got here, and that right there, that 0.2 was that 4 over the square root of it. So you're going to have to undo all that to get back to calculating your sample size. Okay? So, the population standard deviation for the age of football college students is 15 years. If you want to be 95% confident that the sample mean age is within 2 years of the true population, how many randomly selected foothill college students must be surveyed? Okay, 95% certainty. We've got that formula again. Okay. Your sample size. Oops, I skipped it. Your sample size, n, is going to be equal to your multiplier. That's on the chart. Okay, we're going to go get that. It's related to that 95%. We'll find it out. Then you've got the standard deviation squared. And they gave us our standard deviation here. And then the error bound, error of the mean. It's going to be within 2 years. They want it to be that. What is your n? How big is your survey? So if we want it to be 95%, we're going back to the chart. 95% is 1.96. I want to print that slide out if you need to do these. But 1.96, we're going to get, that 1.96 squared. Okay. Standard deviation is 15 squared divided by 2 squared. All right, so you're going to have to multiply this out. 1.96 squared times 15 squared is 225. Okay. Divided by 2 squared is 4. Gives us 216.09. So, we're going to need to randomly select about 216 students to keep that 95% certainty. Okay. Population standard deviation for the height of a high school basketball players is 3 inches. So, we've got standard deviation, 3 inches. If we want to be 95% confident is within 1 inch, how many randomly selected students must be surveyed? So once again, we have our formula, your multiplier, and we're using the same 95%. Then your standard deviation squared over your error bound squared. Multiplier 95% confident. Once again, that's the same one. So we got the 1.96 squared. Your standard deviation here is 3 inches. And your error bound within 1 inch. So that was just a 1 on the bottom. So we're going to multiply this out. And I'm going to get 1.96 squared times 3 inches squared. And that equals 34.6. Not a whole lot of students, so roughly 35 students. Okay. Or I guess basketball players, if you're looking at the high school basketball players. But that's it. You just use that formula to find out how many you have to get surveyed. And that's the last video of the course.